Good morning, IPXers. As you can see, as you know, I have a really tough life. I'm in California, Los Altos, home of the great disruptors, home of Apple, Nvidia. Are they disruptive? Not quite sure. Everybody tells me they are. AI, everywhere. Anyway, real disruptors come from places like this, Silicon Valley, sunbathed. And I'm meeting a company today called Visionary.ai, a man called Dave, who's going to make my life the easiest ever demo on how his company clear up images coming in from sensors, images coming in from cameras, and can show you the difference of how their technology works with what you might think is pretty high-powered chips, but they can actually take their technology. It doesn't have to be running on a super turbocharged chip. It can run on a much smaller chip, and you can use in your application today. You're going to love this demo, so let's walk over to Dave now, and he's going to show us how he solves these problems. Nice to meet you.
Nice to meet you.
Thank you for having us this lovely Sunday morning.
Yes. Welcome to Los Altos.
I know, it's tough, isn't it? Yeah.
Yes.
He lives here. Tell us all about Visionary AI.
Yes, so Visionary AI is a 3-year-old company. We're based in Israel. We have 20 mostly image scientists that are applying
Image
AI.
scientists.
Yes. And embedded engineers.
Right.
That are working on the image quality software that is a neural network that runs on embedded systems.
Yeah. So in simple language, you've got cameras all over the world, either in consumer devices like phones, cars, industrial applications, medical, where a camera's looking at something and the image needs, if you like, lightening up, tidying up, so you get a much, much greater look at what you're actually looking at. And your software is sitting on these chips, and it takes those images and it cleans them up, makes them much, much clearer.
Exactly. So inside of every camera, every embedded system is an image signal processor, which is in hardware is taking the noise out of the image. And what we're doing is enhancing, before that image signal processing pipeline, we're enhancing the signal that's coming from the camera by removing the noise. Essentially, what we like to compare it to is like steroids for the camera.
Right.
So we could take a very low-cost image sensor. We could make the quality of that image sensor higher. We could take a military-grade night vision sensor, and we make the image quality of that sensor even higher.
Right. So, forgive the pun, but it's across the whole spectrum of light.
Absolutely.
Right. Just one question. Why do you use the word noise when you're describing an image?
Yes, because all image sensors naturally produce noise, particularly when the analog gain, there's more light taken into the image sensor. So that's stressing the image sensor, the image quality, and that noise needs to be removed. What we're doing is simply doing the same classical techniques that have been used in image processing since we've connected cameras to silicon, and we're using AI to clean up that noise before sending it down the image pipeline.
Right.
And this can run on any device. What I'm showing is on a cell phone because that's a nice portable version.
We have a very cool demo coming up. So let's just talk about exactly what's going on there. Let's just start at the beginning. We are going to show a demo using a typical cell phone, but you're talking about all types of image sensors. Your software is entirely comfortable sitting on any kind of sensor, or the chip will get the images coming. So how does the AI work? What's the AI part of how it cleans up that noise? What's going on there?
Exactly. So we're a neural network. So ideally we run optimally in a neural network processor. And most of the more advanced embedded systems have some sort of a neural network processor embedded in them. That's the ideal solution for us. It doesn't have to be a large microprocessor with a large neural network processor. Could be a smaller one, but it does need to have some kind of dedicated neural network processor and PU.
Right, because that's quite an important point, because you quite often look at these kind of applications and you'd be thinking maybe something like a really, really big chip like a Qualcomm Snapdragon, which is using a lot of power, very pricey. But what you're saying is actually in some of these other industrial applications or medical applications, your software is very happy to be doing its job, for want of a better phrase, lower down the food chain with typical 32-bit micros, so long as you've got that neural part sitting next to it doing that job.
Exactly. A good example is if you wander, we were talking earlier about embedded world. Yep. If you wander around embedded world, the micro suppliers, ST Micro, NXP, Renesas, TI, all of those companies are offering at the higher end of their embedded processor line, a processor that has an embedded neural network processor, and we can run on any of those connected to the camera, and a lighter version of what we're going to be showing today connected to a smaller image sensor.
The point being is you shouldn't be afraid of looking at these type of applications, like as we're going to show on a typical cell phone. Don't be afraid that you can't use this kind of software in your application to tidy up the noise in the image that's coming back from the edge, thinking that you have to have some big, bulky, powerful processor, because what Dave's saying is you don't. So we've got to get to this demo because it's good fun, and it will very easily show what I can't explain, but he can, using this demo. So Dave, show us about this demo. Now, what have you got in that box?
Okay, what I have in this box is essentially my
you're a magician.
Yes, my portable darkroom, and this is to demonstrate in a dark environment using our software. So what we have here is a Snapdragon QRD. It's a development platform for the Snapdragon Gen 3, which is their latest Android phone.
So just so we're clear, it's looking down into the box now, which we'll show you.
And we get a very crisp image of what's going on. We have a cityscape. We've got Buzz Lightyear and...
Never done a demo with Buzz.
Yes, and not sure who's Buzz's partner is there, but...
Are we allowed to talk about that?
But we have the movement here because we're demonstrating that this is all happening in real time.
Absolutely.
Which is the most challenging part of this kind of algorithm, because we have about half a frame of latency.
Yep.
And in order for this to be useful for both machine vision or for a human eye, so what we're showing here is the exact same phone, same sensor. It's a 50 megapixel sensor, so you can imagine with a much smaller 2 megapixel sensor.
Yep.
We could run this with a.
So you got so just for the sake of the conversation, you're perfectly comfortable whether it's 50 megapixel or 2 megapixel.
Yes.
Perfectly comfortable in both those environments.
Yes, and obviously the amount of computing power to keep up with this latency, about a half a frame or a frame of latency at lower power, is going to scale down with the size of the image sensor.
Yeah.
And what we're showing here in the smartphone is more of the extreme case, because the image sensor size is quite large, and we have quite a bit of processing power.
Right.
But for my favorite application that I was describing before, the sewage inspection system.
Yeah. No, just explain that. Explain that now. Explain that now.
It's one of my, in my experience as one of our partners, Freescale, now NXP, one of their customers that came to my previous company for help was had a robot that inspected the sewer lines. And this kind of application would be perfect for that type of a system where it's a very dark environment.
Quite a dirty environment.
A little bit of a dirty environment,
Yeah.
and then we need a very clean image. So I actually have in my demo one more thing that I can show you.
Yeah.
Okay, so what we're looking at is on the right side we have the reference platform running with our software, cleaning up the image. We're brightening up the image a little bit, that's being done automatically, and removing the noise. The left side is exactly the same system, same SoC, the Snapdragon. You can see a little bit of movement, but you can't really see the what's going on in my portable darkroom.
No. So just so we're clear with the demo, this is looking into a box, which we'll show you when we open the box. This is exactly the same phone, using exactly the same processor, using exactly the same camera sensor. One's taking it in using your software, one isn't using your software. That's what the one using your software sees, unless the one that's not using your software sees. And as you can see, it's literally light and dark.
Exactly. And then, so we can take one more phone. Now we're comparing a much more expensive high-end phone, 1.2 micron sensor, versus a mainstream 1 micron sensor, and you can see that not only is the quality equivalent, but we're able to brighten up this image and getting a much better night view with a much lower cost sensor.
So Dave, so the video, so the watchers don't think you just made up a whole bunch of magic. Let's just open the box.
All right.
So they're absolutely sure that what they've been seeing was actually taking place. Moment of the big reveal.
Okay.
Moment of the big reveal coming up. Big reveal, big reveal. There's Buzz. There's Buzz and his little friend. That was what you were looking at in the dark box through the little hole at the top, and you can see there was entirely lost in darkness, and that was what was going on real time using those two different cameras, perfectly showing you how the Visionary.ai software was taking in the noise of an image, which I still can't get my head around that you call it the noise of an image, but it's how you refer to it, so I'm going to go with it. Tidying it up and then giving you basically what looked like a daylight scenario.
Exactly.
I think that's one of the best demos we've ever done on ipXchange. Thanks, Dave. Absolutely brilliant. All the way we had to come all the way to Los Altos to see that, but it was very, very worthwhile. Thank you.
Thank you.
Hey, where my engineers at?